I'm going to use this representation to show you some of the chemical properties of aluminium. Now that we have discussed them, now you can see here I have 2 molar hydrochloric acid, aluminium foil, some beakers. I have sulfuric 6 acid, that is 2 molar sulfuric 6 acid and concentrated sulfuric 6 acid. I have nitric 5 acid, that is 2 molar and a beaker. I have burner, bottable burner, and some aluminium chloride, so that we can see some of the properties of this aluminium now that we have discussed them above there. We are going to use this aluminium foil to do some of the chemical properties of aluminium. So I'm going to cut some of it for the test by reacting it with HCl. Remember, we are going to do the reaction of chlorine with acids. Here I'm going to react it with dilute sulfuric 6 acid, with concentrated sulfuric 6 acid, with nitric 5 acid. I'm going to try to burn it so that we can see whether it is going to burn. And also I'm going to use aluminium chloride to prove to you that aluminium chloride can sublime, because this one is formed when aluminium reacts with chlorine. Now we are going to do our first test, whereby we are going to place this hydrochloric acid in the beaker like that, then drop this aluminium foil inside our beaker. The reaction might take some time to start, because first there is a coating of aluminum oxide in this foil, but after that it is going to get depleted very fast. So just looking inside here, the reaction starts slowly, because first it has to remove the coating of aluminum oxide that was formed on the aluminum foil. Then later it is going to become more and more vigorous as it produces some fizzing, which you can hear due to the production of hydrogen gas. So it is going to get depleted at the end of the reaction to form aluminum chloride and hydrogen gas. So that is the reaction of aluminium with HCl, whereby aluminium reacts with HCl to form aluminum chloride and hydrogen gas that you can see inside this beaker as effervesces. You can hear the voice of the sound of the effervesces and some gas that is being liberated from the reaction. Our second reaction is reacting it with dilute nitric acid. So again, we place our aluminum foil inside the beaker and add sulfuric acid. So what you can see, there is no reaction, no apparent reaction. Getting back to the one for HCl, it is still reacting and even more vigorous as hydrogen gas is being liberated, and also at the end of the day we're going to have aluminum chloride being formed. For the one of sulfuric, no reaction. But this aluminium is quite a strong reducing agent. Therefore, it can reduce sulfuric 6 acid that is concentrated, which is with us here. I'm going to open it. And after opening it, I'll add it inside our aluminium. As we wait for some time for it to react. Remember, as usual, the coating must be removed for it to start reacting. Then we get to the other reaction. Remember, up here we have said that there is no apparent reaction, but it can reduce concentrated sulfuric 6 acid to sulfur 4 oxide gas, and it is oxidized to aluminium sulfate, and the equation of reaction is here, whereby aluminium react to sulfuric 6 acid to form aluminium sulfate, water, and sulfur 4 oxide gas. Then we are going to get to this part whereby we're reacting our aluminium with nitric 5 acid. We will add it there. If you can see well, there is no apparent reaction. But if we are going to use concentrated nitric 5 acid, it will just form a thin layer of aluminium oxide and will not react. So aluminium is not quite that reactive, and we are going to try to burn our aluminium, and we will burn it on our portable burner and see what will happen if we try to burn it on our portable burner. So if you can look at the reactions, starting with the one for HCl, it is now done. Inside there it is aluminium chloride. The one for sulfuric, it has not yet started. The one for sulfuric here, it has not yet started because there is no apparent reaction. That is for dilute sulfuric 6 acid. For the concentrated sulfuric 6 acid, what is happening? It is reacting slowly because of the formation of aluminium oxide coating. Then the one for nitric, no apparent reaction due to the formation of aluminium oxide coating. So I'm going to burn my aluminium. What you will see, it seems to burn completely like paper, and you are seeing it is getting even red. But if I remove it, it returns back to be the same aluminium. The only thing that has changed is a white coating of aluminium oxide that has been formed there. And then now, finally, we are going to do something with our aluminium chloride. So here is our aluminium chloride. I've placed it in a boiling tube and I'm trying to heat it. So what I'm trying to present is going to be seen in this reaction, whereby aluminium is not going to do what I expect you to say. I don't want to share it until you see it. So because it was hydrated, you can see some of the water on the top of the boiling tube. But there is something that is happening at the cooler parts of the boiling tube. The formation of this aluminium chloride. So aluminium chloride sublimes. So if it is heated, it forms white fumes, and these white fumes, they are going to sublime on the cooler parts of the apparatus, and our apparatus for this case is the boiling tube. And this is the representation that I wanted you to see in our setup today. Thank you so much. And now I'm going to get to this final part, that is to show. Somebody can say that these are not acids, but I want to prove you that these are acids. I'm going to take this solution of 2 molar sulfuric 6 acid that is not showing any reaction and pour it down, and you'll see something. So you can see it is reacting with the flow. So this is sulfuric 6 acid, but it is not reacting with aluminium. I'll take nitric acid, which has not reacted here, and pour it down. You are seeing it corroding the surface there, but inside here it is not reacting with our aluminium.